All right, welcome back. So this time we're going to go into billing and cost management. But before we get started, hit the like button, subscribe, and share with anyone you know taking the GCP ML or Machine Learning Associate exam. So how do you understand billing accounts? Every project that consumes GCP resources must be linked to a billing account. This is a financial construct that pays for resource usage. Billing accounts connect to payment methods, credit cards, bank accounts, invoices, and accumulate charges across all linked projects. Organizations typically structure billing in one of two ways. Centralized billing. This is a single billing account that funds all projects across the organization, right? Finance will maintain one payment method and receives one consolidated bill. This simplifies accounting, but provides less granular cost tracking. Then you have departmental billing. Each department or business unit has its own billing account. The machine learning team's billing account would fund machine learning projects, data platform would fund data warehouse projects. This provides clear cost attribution and enables department level chargebacks. All right. Next, you have cost management. So this is important for machine learning workloads. So ML workloads can consume significant resources. You're talking GPU accelerated training, massive data storage, continuous model serving. Without proper cost management, experimental training runs or forgotten endpoints can generate surprising bills. Then you have to worry about budgets and alerts. This is the most important cost management tool, right? You go to billing, you go to budgets and alerts in the console, and you create a new budget. And you have to specify a couple of things. One, scope. Which project does this budget cover? You can create separate budgets for development, for production, etc. Then you set the budget amount. This is the spending threshold that triggers alerts. Then you have alert thresholds, right? So percentages at what you want notifications. That could be 50%, 90%, 100%, however your team needs to configure it. And then you have notification channels. This will be emails or pub subtopics that can receive alerts. And so when spending will reach X% of a budget, stakeholders receive an email notification. At Y%, escalations can go to managers, C-suite, etc. 100%, you might trigger an automated response like disabling non-critical resources. Okay, so cost attributions, all right? Cost attributions need labels. Labels provide metadata for organizing and tracking resources. And these are applied to virtual machines, storage buckets, BigQuery datasets. But basically, labels enable cost analysis by category. So you could label all resources by environment, think dev or prod or UAT. You could label it by team, think machine learning, research, machine learning, production, right? Or you can label it by cost center. That could be machine learning, that could be marketing, that could be finance. And in billing, you can create reports where you can filter and group costs by label values, answering questions like, how much did the machine learning research team spend last month? Or what percentage of our machine learning budget goes to development versus production? All right. And then you have your cost optimization strategies. Okay. So you have a couple of things that need to come into play. The first one would be right sizing your compute. So Vertex AI training allows specifying machine types. Don't default to massive GPU instances for small experiments. Start with the standard CPUs. Scale to GPUs only when training time becomes problematic. 2, preemptible and spot instances. For fault-tolerant training workloads that can handle interruptions, preemptible VMs cost 60 to 91% less than standard instances. Your training code must implement checkpointing to resume after preemption, but savings justify the engineering effort. Third would be storage class. So cloud storage offers multiple storage classes with different pricing. You have standard, which is a frequent access, higher cost, right? Then you have nearline, which would be something for monthly access. It's about 50% cheaper. Then you have cold line. This would be something for quarterly access and about 75% cheaper. And then finally, there's archive, which is made for annual access. It would be about 85% cheaper. So training data sets in active use belong in standard storage. Once training completes and models deploy to production, archive the training data to cold line or archive storage. Use lifecycle policies to automatically transition objects between storage classes based on age. 4, cleaning up your unused resources. All right, development leaves debris. This could be experimental Vertex AI endpoints, outdated model versions, temporary BigQuery tables. You basically need to periodically audit your resources and delete anything no longer needed. A forgotten GPU backend endpoint serving 0 predictions could still cost $200 a month. And finally, 5, monitor your cloud billing reports. That's why we started with the billing. If you go to billing, you go to reports, this can provide detailed cost breakdowns by service, by project, by time period. Review these reports monthly to identify cost trends and anomalies. If BigQuery costs suddenly spike, investigate whether someone ran an expensive full table scan query. So that'll be all for this one. Before you go, hit the like button, subscribe, share with anyone you know taking the GCP machine learning exam. Thank you, and have a good day.